Hello my dear students, this is Akash HD. Welcome to the ASD Physics classes students. I hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter Thermal Properties of Matter, and the topic is Stefan's law. Okay, so let's go through the question. The question is, a spherical black body with a radius of 12 centimeter radiates 450 watt power at 500 Kelvin. Okay, after that, if the radius were halved and the temperature doubled, okay, then the power radiated in watt would be how much? Okay, so remember that here the which kind of body is there? The spherical black body is there. So remember that here for spherical black body, the relative emissivity value is always 1. Okay, next thing, what is given? The radius. The radius, it is given here how much here? R1, 12 centimeter. Okay, so this radius is given here 12 centimeter. After that, the power, how much is given here? The power is given here 450 watt. Okay, we are just noting down the data here. Okay, next one, temperature. Temperature T1 is given here 500 Kelvin. Okay, now after that, what is given? If the radius were halved. So what is the meaning of the radius halved means? Remember that here, radius halved means, remember that here, this R2 equal to R1 by 2. Okay, and what about the temperature? Temperature doubled. Okay, so we can write here T2 equal to 2T1. Is it? Now after that, they are asking what is the new power. Now, so this P2 we have to calculate here. Is it? So this is the given data, these are the changes are there, and we have to calculate here the new power. So here I have taken here one spherical body is this. So what will happen that here, if this body is having some temperature T, so what will happen that here, from here the radiation will come out. Okay, and remember that here, according to Stefan's law, which law is there? Stefan's law. Stefan's law. According to Stefan's law, remember that here, energy radiated per unit area per unit time is given by sigma T to the power 4 into ER. Okay, where Q is the energy, A is the area, surface area, T is the time, and sigma is Stefan's constant, T is anyhow temperature, remember that in a Kelvin, and ER is water, relative emissivity. Okay, so after that, here in the question they are talking about the power. So power means what? The power means the rate of energy, na? With how much rate the energy is just emitting. Okay, so this Q by T will become here power. What I am telling here students, this Q by T, this Q by T will become here power. Okay, so Q by T means power, so I can write here what is the formula here, sigma T to the power 4 into ER into A. Okay, so this is our formula. Is it? This is the main formula, remember that here. Now on this formula we have to apply our conditions. Okay, so remember that here anyhow the sigma is constant and ER value how much here? 1. Okay, and area of cross section of the sphere how much here? Not cross section, surface area. So area of the sphere how much here? 4 pi r square. Okay, so if in case I write here, remember that here P is given by sigma T power 4 ER, and area how much here? 4 pi r square. 4 pi r square. Now this is the temperature, this is in a side. Okay, now after that what I will do here, I will just take here what are the variables are there. So temperature is the variable and R is variable. Other things and all we can consider constant with the value of ER is 1. Okay students, so kindly see very well. So if I see from here, I can write here, see, from there I can write here P is directly proportional to T power 4 into R square. Is it? Other all things and all constant. Now after that, if I write here the P2 by P1, see, P2 by P1 is equal to what we can write here, T2 by T1 power 4 into R2 by R1 square. Is it? Now after that we can write here this P2 by P1 is equal to, temperature is becoming how much here? Twice. So we know T2 equal to 2T1. No? So we can write here, see, this 2T1 by T1 power 4. Radius is becoming how much here? The radius is becoming half. Okay, so I can write here R2 means R1 by 2 by R1 square. Okay, now after that what will happen? This T1 cancel, this R1 cancel. That means we can write here P2 by P1 is equal to 2 power 4 into, here it will become here 1 by 2 square. Is it? So when I will simplify this P2 will come here, 2 power 4 by 2 square means 2 square, that means 4. So it is coming here P2 equal to how much here? P2 is coming here 4 P1. Okay. Now after that what will happen at here? We'll put here the just value here. So P2 means 4 and P1 how much? As we know in a question, 450 watt. 450 watt. So we'll simplify this here. 0, 4 5 ja 20, 4 4 ja 16 plus 2, 18. 1800 watt. That means what is the new power is coming? The rate of energy emission is coming how much here? 1800 watt. Okay, 1800 watt. Kindly see very well. How much coming here? 1800 watt. Is it, students? So if we see here, which option is matching here? You can see very well. The correct option is here, option C. Kindly see it. So students, I hope so. This question based upon Stefan's law, you have understood very well. Keep studying, keep growing.